Hello to everyone, and you are all indeed very welcome to today's webinar, where we'll be taking a run through the preview features of MasterSeries 2020. My name is Martin O'Gara, and I'll be taking you through the presentation today, and answering questions on the side is my colleague Tommy White. So if you have any questions, there is the questions box. You can simply pop your questions in there, and we will answer those as we go, and hopefully take a roundup of some of those questions at the end. Can I first of all just start off by saying that it's fantastic to see so many of you here today. Still plenty of people still in the processes of signing in. We, I think, have a record turnout today. I'm sure many of you possibly joining us from not your usual office environment, perhaps from home. Obviously, many of us have experienced considerable business interruption over the last number of weeks, and really just to say it's been our pleasure to be able to support you through that, and we've been extremely encouraged by how resilient and how you guys have coped with everything that has been thrown at us this last number of weeks. Just to reiterate that we are here for you, we're here to support you, we're 100% business as usual. Albeit we are ourselves flung in lots of different locations, both geographically and otherwise. So if you need any help or support or assistance with your remote working arrangements, we would be delighted to hear from you. So we're here today to have a look at what's coming down the line in the MasterSeries 2020 version. So let's just get stuck straight in. One of the new features that we are most excited about, and probably will spend more time today on than anything else, is our new module for slab design called MasterKey Finite Element Slab Design. This really offers us a very much a graphical design methodology of placing reinforcement to design for main reinforcement and also for punching shear reinforcement. There's been a considerable development effort put into this new module over the last number of years, and we're delighted to see this come to fruition. So there's a lot of detailed and extremely well thought out workflows and also design implementations together with the final processes of being able to produce design reports and also design intent drawings for detailing purposes. So we're going to be looking at that in a bit of a high-level overview. We've also got a new interface in our MasterKey Masonry design module, and we've got a new interface for MasterKey Masonry. This really presents a new way of working in terms of the layout of the interface. Gone are the tabs at the bottom, and in is a lot of very well thought out and very well laid out design input dialogues, which are just as accessible as the old tabs, but offer a lot more space and clarity in terms of design input, and also the accessibility of your design inputs through the very nicely designed top toolbar. Really makes things quite a bit easier in terms of how things are segregated and split up now. Also, a lot more real estate is offered for the design output and the graphical areas as well, which are also a little bit more interactive in terms of that. Just a small note that PowerPad users who do have MasterKey Masonry design in a limited version now do get the two opening design methodology using the traditional sub-panel methodology, not the advanced yield line analysis. Sorry, guys. But that really will offer you the ability to do a little bit of opening design, but obviously the advanced yield line analysis, which is a full version feature, really lifts the lid in terms of the capabilities of opening design. We have a really cool new feature in MasterFrame called CAD Layers, and that's the ability to import a CAD drawing and have selectable, snappable entities from your drawing able to be drawn over. So that really does offer a lot of good facility in all the different areas of MasterSeries. So that really offers you the ability to snap onto drawing entities on this CAD layer, and you can have multiple CAD layers. Those can be anything that you want. Could be a floor plan layout showing your structural entities along with block walls for the placement of line loads. So the application of that is quite extensive, and very, very helpful. Connection design really gets a nice up-to-date interface in terms of its top toolbar. And also we have a great new feature in the connection design called a template database library. This has been pre-populated with a lot of different joint configurations for each joint type. For those of you who are users of the software will know previously, when you created a new joint, you simply get one type, one default setting per joint type. You could, of course, control that, but now effectively you've got a whole array of new joints you can create for any one of your joint types. And the great thing about it too is that you can extend this template library by adding in your own templates in a very much controlled fashion, and with everything able to be very much filtered and with tags for you to find potentially this new template that you're looking for that will create the joint that is closest to the one that you're trying to create just now. Some things we won't actually lay eyes on today, but just to make a note of them, some BIM improvements. We are using a new engine for DWG DXF in all areas of MasterSeries, which has allowed us to do DWG import and export in all areas, as well as DXF. So previously it was DXF, we're now supporting DWG, and indeed the latest versions of those standards as well. And of course, when you're now exporting to any of those, you have the option of choosing which standard of CAD drawing or DXF version that you want to choose from. Importing of DWG DXF files, which is different from CAD layers, but for those of you who are users of MasterFrame will know that previously you can import a DXF file to actually create structure by selecting which layers you want to create members from. Those members can now be used. Curved lines in those drawings can be used to create curved members. Another nice new feature is the ability to nominate a layer in that import process for the creation of grid lines. Revit sees the import and export of curved members in the similar fashion, as well as a new library or family that we have added to our Revit add-in installation to facilitate the import and export of web openings, discrete web openings from MasterSeries to Revit. Also a note on the MasterKey wind analysis. Considerable work had been done early in the year with regards to the implementation of a new wind analysis engine from the SCI called Win360. Really, really nice new feature, new facility from SCI presenting a web-based web service engine to calculate wind analyses from wind sites that really used a lot of nice new facilities such as postcode searching, but it also used Google Maps for looking at fetches, and so it was using really up-to-date information and had the potential to be much more enhanced in the future in terms of resolutions and things like that. So we were super excited with the SCI Win360. Unfortunately, there's been a slight delay on the SCI side in terms of bringing that online and provisioning that. So as soon as that's available, we're ready to go in terms of the implementation of that. And we'll keep you up to date when that is announced. Another really nice new thing is a lot of considerable work has been undertaken this past couple of years, really, in terms of provisioning a new web-based help system, not a PDF format, but actually a searchable HTML web help system, which presents a really up-to-date interface in terms of looking for help content. And it also has some really cool context-sensitive integration, particularly in the MasterFrame. So when you're looking at an area, you can press that F1 key and get the help that you need. Updated tutorials as well have been extensively worked on, and extra tutorials have been added. So we're going to get stuck straight into having a look at some of these things. And here we have our front screen of MasterSeries 2020. Not a lot to change in this area. This area obviously saw a significant change in MasterSeries 2019. So we're going to get straight into our MasterKey concrete slab design first of all, using this little file that we have previously created. The generation of this file, many of you will be familiar with the processes involved in this. Not a lot changed on that regard, but we do now obviously have the ability to go and do some design. I'm going to have a look as well just at the design of the first floor. So we have here an arrangement of two slabs with two different directions at each level. We have an arrangement of walls, columns, circular columns, some columns offset from the edges. So let's have a look at the design of level 1. And let's just go to design and concrete slab design. The first thing I'm presented with is a series of defaults which will be the starting position, if you like, or the initial data for a lot of my subsequent reinforcement that I'm about to place. So the default covers, grades, layerings for main steel, for punching shear, any basic or background reinforcement that I produce, what's the starting position for that, although that can be changed on a bar set by bar set basis. So the basic premise really is that we're going to try and provide background or basic reinforcement throughout, and then we'll see where we can need to address additional reinforcement. And what we call two areas, peak zones and strip zones, are my methodologies of adding in additional reinforcement where the basic isn't adequate. And there's a lot of detail in terms of how that can be arranged and how it can be combined with the basic or replace the basic, and what configuration these different sets of rebars actually take place. My challenge today is not to get too bogged down or in depth and in detail on this. I could talk about this for possibly an hour and more, but I'm going to try and really limit this to pretty much a high level overview at the moment. So on to strip zones. So peak zones are basically what you might expect to see over a column head. Two sets of orthogonal bars in over a point where you've got concentrated stress. You've also then got strip zones, which are similar to peak, only they've got reinforcement just in one direction, again for addressing areas of additional force or concentrated force. Finally, in terms of the auto design, you've got control over the selection of bar sizes and the spacings of bar sizes that you want, so you can edit these to limit the selection of auto design that you want. So let's just save that and we'll get straight into the interface. I'm going to take the 3D off, and I'm going to also come along here and turn off the drawing of the finite elements themselves, just to clean that up a little bit. So my first job really is to place one of these basic sets of reinforcement. I can see my peak, my strip, and subsequently my punching, as we'll come to as well. So let's add in a basic bar set. And the first thing to say is that placing this on a selected FE surface, which is really a selected slab, I can draw a region, a drawn region as well. But initially I'm going to say, yeah, I've got some basic reinforcement on this slab and also this slab. So straight away we're getting some design based on this basic reinforcement over the entire area of these two slabs. And I can also draw that reinforcement. So I've got the bars in direction 1, the bars in direction 2 on the bottom and on the top. So that's all the rebar that I have at the moment in those areas. So how is this reinforcement performing? Not very well at the moment. Not too bad on the bottom, but obviously, as we would expect, not very well on the top, because really our job is to supplement the top with additional peak reinforcement. Now, one of the things that you'll find very, very useful in terms of assessing what your basic reinforcement is like and where you need additional is some of the contour output settings in this area. We can, of course, come along and look and say, initially we could say, okay, what is the bottom AS required, and to give myself an understanding potentially of how much basic steel that I might want in the bottom. But really, by and far, the best way is to put in some basic, and then we can come along to our unity ratio. So this is the moment of resistance unity ratio for the basic reinforcement in the bottom in the x-axis. So I can see straight away that for the vast majority of the slab, the basic reinforcement is doing just fine. A couple of areas over here where we can see it failing. We have a very clear distinction between passing and failing color zones, so we can easily see what's going on there. For the other direction, we are mostly good. A couple of the points that pick out the key design are highlighted. So we've got here, we zoom right down in, we can see a little bit of a problem there, which represents this design point here, which we'd be more than happy to accept and ignore as that little point of singularity at that corner of the opening. So we'll address the bottom reinforcement subsequently, but let's have a look at the top reinforcement and see what we can see with the unity ratio entity there. So we've got here now, obviously, as we would expect, the areas of the slab where the basic reinforcement isn't working for what effectively is the direction 1 bars. For the direction 2 bars, we can see a similar type of scenario. We can see obviously above our wall here as well. For the YY, we've got some failure here. Or we can look at the combination of both of those, really, which gives us the entire areas over which the top reinforcement isn't adequate. And that gives us a very clear view of where we need to provide additional peak reinforcement or potentially additional strip reinforcement over the tops of these walls. So I suppose just to try not to get into too much detail, but this basic reinforcement is orientated with the local surface x-axis, currently sitting at 0 degrees. It can be skewed, but I haven't set that as such. So this is a reinforcement that is effectively aligned with the local surface x and y axes of the slab, but it can be offset and adjusted to be otherwise. Okay, so let's do the job of applying some peak reinforcement into peaks, and let's add in my first peak. So add a peak, and let's just pick on a point to place it. Okay, so what have we got here? I'm just going to spin myself around a little bit. And the first thing to say is that this is additional to the basic reinforcement. I have told it that I wanted to split it up in over 2 zones. So you might wonder, well, where did the 2 zones come from and what does that mean? It effectively means, as we can see from the strip lines, that we've got bars in outer strips and an inner strip, outer strip and inner strip in 2 different directions, 2 different orthogonal directions. Where does that notion come from? Well, effectively, it's a code thing. The design codes of practice previously advised us when we were looking at column strips that over column heads, we would place 2/3 of the reinforcement in the middle half. So you get a slightly heavier zone of reinforcement in the middle half. And you can still achieve that type of reinforcement distribution using this 2-zone design. There are a number of different layout options available to you, which we'll try not to get into too much detail on here at the moment. Or if you want simply just 1 zone, you can do that by saying, well, I've only got 1 zone of reinforcement over this whole width. These are using the key concept here is this is using not reinforcement at a point, but design strips that are strip averaged over a design strip width. And one of the things we've been really careful about is ensuring that you as an engineer potentially don't do things like over average the reinforcement over too wide a design strip width. And the program does have upper limits of what it will do in terms of strip averaging, and you also have control, so you can do things like ensure that your strip averaging doesn't happen on anything more than over 5 effective depths, for instance, which seems to be a good, we've did some research on this here and had a look at what really is acceptable there on that basis. One of the things, I suppose, to concepts to get your head around is that we are moving beyond the concept of traditional column strip, middle strip, because those types of adages, whilst they were useful when we were doing equivalent frame analysis methodology for placement of reinforcement, we aren't necessarily bound to those principles anymore, and we really can do whatever we want within sound engineering principles. So what have we got here? In this peak, we've got the basic rebar. It has not been sized yet. We can see that the zone is failing. We've got the checking of the reinforcement in the inner halves and the 2 outer halves. We can now do a design of this either by selecting bars ourselves, or we can do an auto design. So let's auto design this individual peak. That's it. We've got 10s of 200s. Just click on there to show an updated view. 10s of 200s for the inner halves and 10s of 100 in one direction. And for the other direction down here, we can see that it's happy actually just to use the basic as it's averaged it over a design strip width and found that it's actually just fine. So let's continue. When we look at the size of this peak, where did the size of the peak come from? How was that determined? Well, in the peak zone we have some default sizes of peaks. I then put a dimension here, and that's the size it's using. The size that you use will depend on what you want, and this is where the balance between automation and control really comes into play, and that you potentially need to decide, do I want bigger peak zones and smaller amounts of basic reinforcement, or how do I want, what way do I want to balance the reinforcement in my slab? Looking at this, I can see that the basic rebar isn't adequate just outside this peak zone, so I could decide just to click on that little handle and drag it up. I can click and drag the peaks around to size them whatever way I want. Or a really nice feature is something called auto size on a peak. So we can set the peak to auto size, and then when we auto design it, it actually optimizes the size of the peak to the area over which it is required. The really nice thing as well is that the program is also then looking at the stress in the bars and checking their anchorage all the way along the length of the bar to make sure that we've got adequate anchorage from these bars as it intersects with the basic rebar. Things like axial force is taken into account as well in the design, as is important for slabs. So that's taken care of. So let's proceed now and add in another peak to this column down here. And for this one, actually, I might be happy to say that I've got a one zone design, and I'm just going to manually come down and change its dimension to smaller size, and let's just auto design it. And again, we've just got tens of 200s additional in one direction and nothing needed in the other direction. If I just refresh the graphics now of the contour outputs, we can see that these areas are now excluded from the design of the basic contouring, as they are now covered obviously by the provisioning of the additional peak bars. So we're now getting to a point where these areas are now satisfactory in terms of their working. So I'm going to pick up the pace now, and we're going to really apply additional peaks over the remainder of the slab, and we can do that in a much more faster way by using the add draw multiple peaks. And we've told it that we want to place these at column heads and wall ends, so we just window everything, and here we have peaks at all the locations. So I can auto size, or not auto size, the size of the peaks are still going to remain as I determined, because I haven't set them up as being auto size, but I am going to auto design the reinforcement in them. So I'm going to auto design the reinforcement in all the sets of peaks. All is everything, auto design all the basic, the peak, the strip, but I'm just going to auto design just the peaks. In fact, I see some peaks here now that have aligned themselves with this slab instead of this slab, so I'm going to take care of that by windowing a set of peaks, which you can do for any set of peaks. You can window them in their entirety and change everything about them in one operation. So I'm going to set them all to be orientated with level 1 or slab 1 level 1, and that's them sorted now. So I'm just going to do that auto design again, and I can have a look at that reinforcement in the top direction 1 and in the top direction 2. Obviously at this point you might be tempted then to spend some time, and you should spend some time looking at the rationalization of this reinforcement. We could look at this and say, okay, well actually we would like all of these to be the same size and the same amount of reinforcement, and we can just hold the control key down and continue to select more of those. And for all of those zones, I could very, very easily come down and say, well, actually, yeah, they're all the same size. We can draw their dimensions here. So we can say, actually, yeah, we're going to make them all 2.5 by 2.5. Type that in. And also in terms of the rebar, we can choose what we think might be an upper envelope of rebar and have that applied to all of those in one operation. Another strategy at this point might be having allowed the program to auto design with a wide range of selection of rebar, because remember the selection comes from what we determined in the auto design scope here. We could modify that scope, and for instance, looking at this, I can see, let me just see if I can determine anything that's a little bit more unusual. You know, I've got tens at 200s, tens at 100s there, which does seem absolutely fine. In fact, so I might have preferred tens at 100s here as opposed to 12s at 200s. If I wanted to try and stick with 10 mil bars throughout, I could of course come back to my basic data and defaults, change the auto design defaults, and have another run or pass through the auto design to further refine that. So the flexibility is yours. Also, I can control the auto design selection parameters on a rebar by rebar set. So for this peak, I can say, well, actually, no, I only want you to use 10s and a spacing of 100, 200, 300, and that will adhere to those settings as opposed to the global settings. So a lot of flexibility and a lot of really cool features there. So how are we doing in terms of our basic rebar? We're probably getting to a point now where it's looking a lot better. Our top reinforcement certainly is better. Bottom reinforcement, still a bit of work to do. But we can see the top reinforcement now is picking two different critical points. And that's of course because we still have a little bit of reinforcement that we want to place over the tops of these walls. So when we looked at the AS required XX, for instance, we can see, yeah, we definitely need some additional bars here. And this is where the peak zones are, or sorry, the strip zones are your friend. We can add in a strip zone, which is reinforcement running in one direction only. Select a parent surface. And now we're going to draw this in. Now, just before I draw this peak in, I'm drawing in a line, basically a strip line, and the bars are going to be perpendicular to the strip line, and they're going to be on the top as well. They are going to be additional to basic, and they're going to follow these rules in terms of sizings and things in terms of their defaults. So let's draw it in. Zoom right down in here, and let's just pick in the middle of that and go straight up. So I can control the scope of this by dragging it around, or indeed by coming in down here. We do actually have different dimensions. Instead of just 2 dimensions, you've got 4, so it can actually provision a varying bar range, if you like. So although this is placed like this, it actually could be arranged that it's all the bars of all the same length, but placed in a fashion where they're following more the profile of the wall. So because this reinforcement is, we can see the strip averaging line here and the force that's being used for the design. And let's just auto size the reinforcement. So we've got the basic, and it's determined that we're going to have 10s at 250s here. Now it could be that I really don't want 10s at 250s. I would prefer to stay with the same spacing as the basic, and we'll use that instead. So a slightly more conservative design, but one that I'm happy with. Let's apply another strip zone to the other direction. I don't need to be in this view to see this, but just to remind myself of why, as to why I do need extra bars in this orientation as well. So let's get another strip, and it's orientated to the slab, and let's draw it in perpendicular on the top. And we'll just drag that in like that as well. And again, we'll auto size that. Now in this case, actually, it's got a design that's working in terms of the unity, but it is actually failing in terms of a detailing check for the minimum spacing, or the maximum spacing, I should say. I would expect the auto design to adhere to that, so we can look at that, but very easily we can come along and say, no, we're not happy with 300s, and again we will be a little bit more conservative and drop that down to the same as the basic, the 200s. And we're in pretty good shape. Our basic rebar now is still slightly problematic on the top in one of the areas. We can see here this 37.7 coming from that. However, we obviously could make this peak a little bigger, and that would resolve that. But I'm happy to proceed with what we're doing now to overcome that. Great. So having established obviously my main reinforcement, we did have a little problem still in the basic area here. So just to remind ourselves, when we look at the sagging in the X and refresh that, we've got some areas here where the basic rebar isn't adequate. Now there's obviously various things you could do. We could place a strip of rebar in here, providing additional rebar in these areas. Just like we placed the strip over the top of the wall, we can place a strip where the bars run parallel to the strip line and are on the bottom. That would be one solution. Another solution might be just something a little bit more conservative and say, right, in this whole region here, we're going to actually provide a different amount of basic rebar. And we'll just do that as a course of demonstration. So this time it's going to be a drawn region, not selected over the full region. So it is a basic rebar zone, orientated to that surface, and let's draw it in. And we'll simply just pick around and draw a polygon region to provide that. And we are going to say that we're actually not going to use this to provide top bars. The top bars will still be provided by the previous bar set that was applied to the whole surface. But for the bottom bars, we're happy to say that the direction 1 bars are 12mm bars, and we can see that that's passing. If I just do a refresh on the contour graphics, we can see now that this whole area now is indicating that it's satisfactory for that design. Perfect. So we're now at a position whereby our basic reinforcement, or our main slab reinforcement, is practically adequate. We're going to look at some punching shear design. So the punching shear, let's just turn off that graphic, is extremely straightforward. Quite simply, we add a punching shear rebar set or check, and we click on the point at which we want to apply that. So we can see this circular column, and it's clever enough to know that the perimeter pokes out the side instead of just going around this, so it does all sorts of geometry checking to look at that. We can look at the arrangements of the bars. So remember, it's 12mm bars. They are provisioned on a vertical angle. They can be changed. We also then can say that it's spaced on and evenly spaced around the grid. So you can see here, although the design tells us that the perimeter in terms of the amount of bars required is 2 bars, just 2 bars. However, the design in terms of the detailing rules does require 3, 4, and 5 bars on each of these 3 perimeters over which the design check is required. So you can see the perimeters noted here as in your 2D effective perimeter, and then you've also got the outer perimeter, all in line with the code designations. So we are doing Eurocode design here. This will work for British Standard design also. But I can say that I would like a radial layout. Now obviously what that means is that you've got more bars in here, but a slightly more convenient arrangement of reinforcement to place in terms of that. And it may be that's something that you can provide using shear rails if you want to go for that type of layout. So let's get a few more punching shear checks on the go. Let's go for this wall end. So not just column heads, but wall ends are also included. And in this case, they're again equally spaced in the perimeter, but you also have an option here for what's called an even grid. So as you can, it's drawn at a skewed angle, but there is an even grid running through this here, and the bars are then aligned with the grid orientation, and the perimeters pick up the bars and attribute those bars to those perimeters in terms of the checking of the bars. Just a note here on this wall end shear, punching shear check, it's actually sampling the finite element shear force in the slab, and this is what this drawing is around, whereas we don't necessarily get that same experience when we look at this. And that's because there is actually a couple of different methodologies in terms of assessing the shear force that's used for punching shear design. Using the codified method, we're looking at the axial force and moments in the columns, and looking at how that then develops a beta value, all entirely in accordance with the code of practice. However, so we can look at the effective punching shear stress that the code produces of 0.681. However, we can actually, for columns, also say, well, actually, alternatively, we would like to sample the shear force instead. And the shear force can be averaged over two effective depths if you so desire, but it does actually produce a considerably lesser stress in this scenario because it's able to utilize a little bit more of the perimeter. So it does do a job of, I suppose, looking at the more realistic distribution of shear force, whereas the code methods obviously will limit the distribution of shear force around a certain perimeter and not allow it to go beyond the edge projections and so on. So again, let's pick up the pace and get some of these punching shear perimeters on the remainder of my slab. So I'll use the draw multiple again, and let's window everything. And now I've got our punching shear perimeters on all the locations. Great. So just have a quick navigate around. Not everywhere is requiring shear reinforcement, as we can see. We can see that some of the areas are just fine in terms of that. Other areas that do, you've got obviously the layouts you can experiment with. Interestingly, on this one, you've got a cruciform layout, which is one of the layouts that the Eurocode 2 talks about, in that it does look at an alternative shape of punching shear perimeter, and the program checks that shape and determines whether or not that layout is actually achievable, because it's not always achievable in all scenarios. So this again offers a simplified method of placing the reinforcement using a compromise in terms of the effective length of the shear perimeter. So at this stage, we've pretty much got our slab totally designed, and we can produce some output using the report generator. So we can generate a design report of our design results and graphics using these. So we can simply print or export to Word this report. The report generator that you see up here also participates in this. So there's a new item for slab design results, and you can add that to your overall general report buildup. You can also then export your design intent to the drawing. So let's do that. And we will just include the level 1 outputs because we haven't actually done any design for level 2. And yeah, we want all the bars and all the directions and all the different components. And let's just load up AutoCAD. Okay, AutoCAD's coming up on my other screen, and I'll just drag that across. And there we have our design intent demonstrated with the appropriate keys on the other side also. Perfect. Some people ask us, with regards to a detailed design output, so whereby you can actually get design detail. It's very much an intuitive process of where bars are lapped and spliced in terms of what a detailer does. So we find it often more useful to basically communicate effectively design intent and let the detailer do their magic in terms of working up the final detail. Great. So we're going to step away from the slab design, and that concludes this aspect of the design. There's maybe a further discussion to be had surrounding the deflection checking of the slab. I'm sure that's a burning question for many of you as to how that's actually looked at. And I would stress that that's something we're working on. This offering that we have at the moment is phase 1 of this slab design module. We are working on the detailed cracked section deflection calculations now that we have the mechanisms to effectively provide and provision the reinforcement. We can take the next steps, and we are taking the next steps to look at the deflection checks. The ability to look at the more simplified method of simply conservatively reducing the moduluses of elasticities on a global basis on the slabs is there as per previous, so you can still use that as a conservative approach. But we are working on the more advanced methods of deflection checking, and that will be coming down the line. Great. So we're going to move on and have a quick look then at MasterKey Masonry. Okay, so the masonry design, as I say, it has a new interface. Gone are the tabs at the bottom. We obviously have split the graphics from the output. So you've got more screen space for your output and more screen space for your graphics. And the graphics are also panable, zoomable, zoom to extent, zoom window. You might wonder why the zoom window would be useful, but in some situations it can be of benefit. Now, looking at the top menu bar, this isn't just for viewing things anymore, but this is actually your main interface for accessing your design inputs. So your briefs are manageable and navigable using a lovely set of tools up here, but all of your design input is accessible, and some of your design settings are accessible from the top menu bars. So you can see clearly how this layout provides a much clearer and more transparent method of inputting the values as it gives us opportunity to explain more clearly each of the inputs and what they actually mean in a much clearer fashion. It's also allowed us to split up the interface a good deal more so that you do have more segregation between your inputs. So you're looking at interface which is less cluttered and more specific to what you're looking for. So your wall loads, outer leaf, inner leaf, are separated now from the point loads. I've been closing down this to access the next one, but you can really instantly go from one input area to another by a single click. So your basic lateral loads, which we've designated as wind loads, just to clarify that. And you've got edge loads, general line loads in a tabulated fashion with a lot more nice graphics in terms of explaining what the inputs are expected to be. In plane lateral loads, not out of plane. The provisioning of wind posts and all the settings. The provisioning of openings and their settings is as per previous, but again, just in a nicely updated interface. So that is the new interface for MasterKey Masonry. We didn't intend to spend a lot of time looking at this, so hopefully you'll find that quite easily navigable and a good step forward in terms of particularly for the uninitiated to the software. We think you'll find this quite easy to navigate and find your way around. Okay. I'm going to take another look now back into MasterFrame, and we're going to have a look at the CAD layers that we talked about at the beginning. So let's actually start up a new MasterFrame module. I'm just going to call this CAD 2. So I'm actually just going to click on Snap Grid to create my new structure here, which is really just coming straight into the snaps area for defining new members. And this demonstrates to us basically how the snap area works, in that we have always had for quite some time the ability to work with snap grids and to work with snapping on structures and things like that. But this snap area we thought would be really, really good if we could augment it with an additional layer of CAD drawing entities, and that's exactly what the CAD layer does. So we find CAD layers by going to the View CAD Layer, and the CAD layer interface simply allows us to add in a new CAD layer setting. So we can have multiple CAD layers, so we can have more than one drawing representing perhaps different levels or different sections of the building, and those can be associated with different planes in the structure. So let's pick the CAD layer, and we can now actually see the drawing, the CAD drawing, and we can see there's two settings here. We can say, okay, well, when we see the CAD layer in MasterSeries, in MasterFrame, what layers do we want to see? And I'm quite happy for it to see all the layers, but we could say, right, well, actually, we're not interested in dimensions. We'll turn those off, but I'm going to keep them on. We can right-click on either of those two columns and say unselect all, because I actually am only interested in snapping to the center lines and the grid lines. The other entities I'm not interested in snapping to. Many of these layers actually aren't used, or a standard set of layers. I think this is actually something that was exported from MasterSeries itself. So we go next, and we're going to now hold the Shift key down and draw a window around the part of the CAD drawing that we're interested in including in this CAD layer. In this instance, it doesn't make any difference, but this could be a very large CAD drawing with thousands of CAD entities, and really the more we limit the CAD layer to the relevant parts, then that improves performance and also helps speed up what's included in the drawing. The final thing I'm going to do before I come out of this area is select the anchor point on the CAD drawing as to where it's located in MasterSeries or in MasterFrame. So it's telling me here to use the control key down and just double click to set a point to say, yeah, that's the point in the CAD file that I'd like to anchor to. Okay, why am I not seeing anything? Well, I haven't set the plane yet. Important to say that we need to say what units the drawing is drawn in. If it's something odd, you can say custom. The plane that the CAD view is associated with can be based on a view, which you obviously can set in your frame views. So when you do choose view, if there are views, you can drop the list and choose a view. I don't have any views because there's no existing structure here. But I am going to say it's based on one of the principal planes, and it's the XY plane. And now that I've done that, I can see the CAD layer coming into play with the layers that I deemed to be displayed. And what I will see is that if I move off the front view, off the XY plane that is, I don't see it. Top view, I don't see it, because the CAD layer is only able to be presented and worked with when you're exactly on the orientation of the view plane. So if you did have a CAD layer that you wanted to associate with a grid line, you can do that using your frame views, and then it will align itself precisely with that grid line, for instance, if it's a section CAD layer. You can also do things like revisit that area to update your settings if you want to change anything, or you can use these areas here to pick the two anchor points between the CAD layer and the MasterSeries structure if you have existing structure. So I'm going to then see if I can use this CAD layer now by going to Add Members. And straight away I can see that I have the CAD layer option to turn off and on here. And I can snap on these entities and snap on their midpoints and third points. I can also hover over to get tracking points and see the tracking lines. In fact, the two tracking points there should provide an intersectable tracking snap point for me. So they behave in the same way in terms of their snappability as to MasterSeries structure. So let's get some members in. Now, I didn't need to display the full section profile, nor did I need to display the text titles, but you can see the advantage they offer me now, because I can see that actually, yes, this line represented a 203 by 20346 on that orientation. So I can use that information to assign the appropriate section. Oh, let's see, gone a bit off track here, and let's get ourselves up to the top and snap something in there. Let's just zoom extents there again. And we can keep going on this basis, putting more of these. Now recall, don't be tempted to input the column starting at this location, because that's its physical location. We are intending to create a structural model here. So it's the actual center line intersections that we're interested in. And finally, just for completeness, we'll not spend too much longer on this, but I will snap in my 406 by 17885 UB. And there it is. Brilliant. So you can see very clearly how this can be used when you're further creating grid lines, finite element surfaces, whether you're drawing in loads. So if you're a MasterFrame Pro user, you'll know the 2019 version saw the ability to have loads and patch loads, line loads and patch loads and point loads, very much placed in using these snapping and drawing capabilities. So if you have a layer of a floor plan with your block walls on it, you can trace over the top of that to place your line loads. So you'll find that very, very useful indeed. Fantastic. So time is marching on, as it always does in these webinars, and I just want to then look at quickly some new features in the MasterKey connection design. The MasterKey connection design obviously has a nice new interface at the top, which is very much similar in style to the new top toolbar interface that we have been using in MasterFrame for a couple of years now. So you've got your ability to use all the previous tools that you had on that top toolbar. And I think it's much easier to find things on. The icons are nice and big, and I can clearly see where things are at, and also what the representation of the icons actually mean is much clearer. You've got your ability to manage your briefs and navigate your briefs and your loading cases where that's appropriate for types of joints in the same ways. What I do have that we didn't have before, as I mentioned in the intro, is the ability when we add in a new joint for that to be created from the template database. And this is a fantastic new tool to allow you to say, okay, well, I want to create a new joint, and which one is it that represents the closest match to the one that I'm trying to create. So I can say, for instance, yeah, I actually want to create a stiffened joint with that type, and it comes in with that sort of setup. And the great thing about it is that you can come in and say, well, actually, it is a haunch type joint that I'm interested in, and it's a stiffened one. We don't have any stiffened haunch type joints, it seems. Anything within it, yeah, there's a haunched extended end plate, and I'll create myself one of those. So the great thing, as I say, is that you can also add in your own templates with your own tags. It's very flexible that way. So I maybe take this and change this into a shorter, that's 100, I meant to say 1,000, a shorter haunch. I might come along and the gusset stiffener, extended end plate stiffener, I'm going to take that out, set that to 0. And I might want that as a new type of joint. So I may decide that I want to satisfy the detailing checks and such at the moment so that I'm not replicating these going forward. So it really is just saying this bolt's potentially a little bit too close to the bottom. So let's do that. Let's go for the lower bolts. And the first bolt up from the bottom, we're going to change that to say it's 120. Still a bit too tight. Obviously my size of my slope of my haunch is impeding that considerably. Okay, let's now create that as a new template. So utilities menu, and we can say save this joint as a template. If you want to update an existing template, it knows what template this joint is based on. You can do that where the template is your template. So let's go for short haunch. And the tags I'm going to put on are haunch. So you just start typing the tags, and if a tag exists, then you can add that in. If I said I wanted a tag called short for some bizarre reason, I can see there's no tag called short, strangely. But I'm going to add a tag called short, and now I'm going to add a thumbnail for this as well. So I can just expand that out and say, yeah, that looks like it will give me a good idea of what type of joint it is that I'm trying to create. And now in the future, when you come to say you want to add a new joint, you can say, right, just the MasterSeries default pre-populated joint templates, or the user-defined ones, or all. So I can see mine in the user-defined ones called short haunch, and I can delete that template from this area as well, and I can see my I go all, my little tag coming in there and filtering down to that for me. But going through this, we can see, a good range of pre-populated MasterSeries default types in lots of these different areas for beam to column, beam splice, column splice, simple connections, bracing connections. So this will effectively very much speed up your generation of joints, especially when you populate this with more and more of your own default joint types. Fantastic. Guys, we're coming to the end of the webinar, but I just want to finish up by showing you this new help system that we spoke about. So I'm just going to pop into one of my previous files. And throughout the system, the help menus have been rationalized, but we now have access to the web-based help system. That's just popped over onto my other screen. I'll just drag it over here, which is always up to date on the web, and it's something that we've worked very hard in terms of populating the content of it over this past couple of years. The great thing about it is obviously you can search it. This particular help repository is one that's related to the MasterSeries Integrated Analysis and Design environment. So everything to do with MasterFrame, MasterFrame Pro, and its add-on programs and add-on design programs is all under one roof. You get a separate repository for the likes of Masonry design because it's very much standalone in a similar way of being provided. Now, if I come back to MasterFrame, and if I were to go to something like member loading, we can see from the help menu, as was hinted, you get context sensitive help. So rather than clicking on that menu, if I just press the F1 key, again, that's come across to my other screen, and I can see it's navigating straight into the area to do with member loading with a very much up-to-date and detailed help system documenting all the different types of loads and the ways of which they can be applied. So our support desk is always delighted to hear from you, but sometimes you just want to put your hand in the answer yourself, and that's absolutely fine, and hopefully these facilities will help you do that. Furthermore, the tutorial documents have been extended and updated and rationalized in terms of how they're organized. We've also got the MasterSeries Learning Center, again, on my other screen. And that's not anything new, that was there, but we are working quite hard at the minute in terms of updating this and populating it with a much wider range of content, particularly in terms of MasterFrame, of lots of short videos, updating lots of the ones that were there previously, and making sure that the content is all exactly up to date and also extended. So a lot of these videos, albeit still very useful, some of which do require a little bit of updating, so we're in the processes of doing that. Keep your eye on this resource and do use it. It will be increasingly useful and even more so than it already is. Great. So ladies and gentlemen, it just remains for me to say that I really do hope you enjoy using MasterSeries 2020. So once again, thank you for your time and attendance, and we look forward to seeing you at the next webinar.